first hear a piano piece, your initial thoughts aren't necessarily about the mathematical properties of the music. You might say that the playing sounds nice, to which I'd say thank you, but surely you wouldn't describe it as geometric. However, what if I told you that everything you heard was actually just physics? Piano and physics, as separate systems, share at least one thing in common: sound. Sound is made up of longitudinal waves, or vibrations, standing waves, nodes, beats, and frequencies. Now, all of these may sound familiar, but how do these geometric properties create the emotions we feel when we listen to our favorite song? Let's look at the mechanics first. The anatomy of a piano consists mainly of steel springs, or music wires, and hammers, making it a percussion instrument. The hammers hit the steel springs at a curve, and by having the hammer strike the string indirectly, the flexible string is allowed to resonate for a longer period, resulting in a more harmonious standing wave. To reach a perfectly harmonious standing wave, or a wave that oscillates without moving from its peak amplitude, the strings have to be wound, rather than simply thicker, to reach a mass per unit length, a solution to Pythagorean scaling. If they were laid completely straight out, my upright here would begin to rival the neck of a giraffe. By winding the wires into springs, we're able to efficiently save space without losing out on tone quality. So great, we learned how a piano is built, but I haven't explained yet how these physical components translate into emotional responses, or why, in other words, some chords sound more pleasant than others. The perfect fifth, along with other major intervals, chords, and triads, is considered to be natural due to the notes being played in unison having an integer frequency ratio of 3:2. Consonance occurs when the ratios consist of two integers as such, while dissonance or inharmonics occurs with either rational ratios or with frequencies that are not time independent. If they are not time independent, the two notes, when played in unison to the human ear, become more difficult for the brain to recognize, resulting in the more minor or negative connotation. So, when you play a C, you're not hearing only that given note, but every other harmonic or overtone that belongs in its family, allowing for the time-independent major triad of C, E, G to sound more energetic compared to the slightly different but now dissonant C minor triad, C, E flat, G. So, my piano is not only a physical object, but an expression of physics that resonates emotionally with people. Now, sit back and relax while I go back to playing some math.